Okay, this is feedback for question 5 on the How Fast homework. It's the last question and it's to do with techniques that can be used to follow chemical reactions in order to investigate their kinetics, or how fast the reaction is going. You've got 4 choices, A, B, C and D. A is collecting and measuring the volume of a gas, B, colorimetry, C, measuring the electrical conductivity, and D, titrate with a standard acid solution. You're asked to select the most appropriate method, which means that there possibly is, there could be a couple of possibilities, but you need to choose the one that's the best. Okay, so for reaction A then, looking at the equation, there are no gaseous species there, no gas being made, so nothing that we could collect there. Colorimetry wouldn't work either because none of those species have a colour. Hydroxide and bromide ions are both colourless in solution. C possibly could work there, electrical conductivity. You do have charged particles, but the most appropriate method would be the titration with a standard acid solution. You've got your hydroxide ion there that could react with that acid, neutralise to make water. So answer D. Okay, your next one then, let's have a look at the reaction here. Check your state symbols out first of all. You have got a gas being made, so nitrogen gas could in fact be collected and you could measure the volume. So option A there could be the most appropriate method to investigate. Okay, the next one then, reaction of acidified potassium manganate to give manganese 2 sulfate. So potassium manganate is something that you'll be more familiar with after you've learnt redox reactions in book 4. But potassium manganate then has the formula KMnO4. So like the sodium thiosulfate in the previous question, question 3, this will dissociate into its ions. And this is the manganate ion. And it has a very distinct colour, it's a purple. And if you look at the Roman numerals there for 7, that's relating to the oxidation state of manganese. Just check that out, -2 for oxygen. There's 4 of them, so -8, everything adds up to -1, so that's +7. And when manganese is in its state +7, it gives a purple colour. Now it says here that that manganate then is going to change to manganese 2+. So manganese 2+ then also has a distinctive colour, so we would notice a colour change from purple to a very pale pink colour. So you'd have probably had to have researched that for this homework because, as I say, you'll study this more in book 4. So just to check there, that's going from an oxidation state of +7 to +2, so it's actually a reduction that's happening there. Okay, so the most appropriate way to track that change then would be to use colorimetry, and that will be answer B. Okay, your last one then, the catalytic decomposition of hydrogen peroxide. So checking the state symbols out, you are in fact making a gas, so the most appropriate way would be to collect that gas and to measure the volume. Okay, I think that's it. Brilliant. Thank you.